I want you to do something for a second. Wherever you are right now, just take a look at the device you have in your hand.
Or maybe it's resting on the desk right in front of you.
Yeah, exactly.
Yeah.
You're likely using it to listen to this deep dive right now. Just look at it. Now, I want you to imagine something. What if that familiar piece of metal and glass actually knew you better than you know yourself?
Right.
And what if it became so incredibly efficient, so perfectly attuned to your life, that you completely forgot what it feels like to plug it into a charger?
It sounds a bit like science fiction, to be honest,
Yeah.
especially considering we are also conditioned to treating our hardware like, well, needy pets that require constant feeding and attention.
Yeah.
But that dynamic is on the verge of flipping entirely.
And we aren't talking about some distant future decades down the line. We are standing right on the threshold of the next 5 years. Today, we're pulling our insights from a really fascinating piece of source material titled The End of the Smartphone Era, 2025 to 2030.
It's a great piece.
It really is. And our mission for this deep dive is to guide you through a fundamental reconstruction of the human-machine relationship. We are looking at a near future where your devices evolve from passive tools waiting for your inputs.
Waiting for you to click a button.
Right, into completely autonomous digital twins.
That phrase, digital twin, is really the anchor for the entire transition we're going to talk about today. We're moving away from a world of manual tools and entering a world of proactive partnerships.
Okay, let's unpack this because we really need to set the stage here. This isn't about the yearly incremental updates we've all grown accustomed to.
No, not at all.
We aren't looking at slightly smaller chips or a screen that's a millimeter thinner or a camera module with a few extra megapixels. This is a complete paradigm shift at the most foundational level of the technology, starting right in the silicon. So why is this massive hardware shift happening right now?
Well, it comes down to the physical limits of current computing architecture. I mean, for decades, our devices have been built around traditional x86 and ARM architectures, but those architectures have essentially hit a wall.
They've maxed out.
Precisely. We have maximized the instructions per clock cycle. Shrinking transistors any further pushes us into the realm of thermal throttling and quantum tunneling. They've literally taken us as far as they can go for sequential processing.
Wow.
So by the time we hit 2030, the primary metric driving hardware won't be clock speed anymore. It will be the capabilities of the NPU, the neural processing unit.
But how does shifting the focus to an NPU actually bypass those thermal and physical bottlenecks you just mentioned?
Traditional architectures suffer from what's known as the von Neumann bottleneck. They have to constantly shuttle data back and forth between the memory and the processor in this very rigid sequential order.
One thing at a time.
Exactly. It takes a lot of time and a massive amount of energy. What's fascinating here is that the NPU mimics the parallel processing of the human biological brain. Instead of handling tasks one by one, an NPU is designed from the ground up to handle massive matrix multiplications, which is really all neural networks are simultaneously.
So it's doing it all at once.
Right. It processes thousands of data points at the exact same time, much like how our own neurons fire in a distributed network.
So it's not just faster, it's a completely different method of digesting information. And the real-world impact of that biological mimicry brings massive energy efficiency for the user. Artificial intelligence will be able to optimize background processes and sensor data locally, completely bypassing the huge energy drain of constantly pinging a cloud server.
The radio antenna on your device, the part transmitting data back and forth to a data center, that is one of the biggest power drains you have. When you shift the heavy compute to a highly efficient local NPU, you bypass that transmission cost entirely. The device learns the rhythm of your day locally. It partitions compute power dynamically, literally putting unused sectors of the chip into deep sleep down to the millisecond.
Which means charging anxiety is going to vanish. I mean, we all know that feeling of panicking when the battery icon turns red at 4 in the afternoon.
Oh, absolutely.
But with this highly efficient local compute partitioning, battery life shifts from being measured in hours to being measured in weeks.
Yeah.
You will literally forget the last time you plugged your digital twin into a wall.
It fundamentally changes your psychological relationship with the device when it is no longer tethered to a power outlet. It stops being a liability. And once the NPU solves that energy bottleneck, it frees up the hardware to interact with the physical world in radically new ways.
Which brings us to how the device actually sees the world. The evolution of the camera hardware detailed in the source is wild. It isn't just about capturing higher resolution images anymore. The physical sensors are branching out into 2 completely different pipelines. First, the source details the camera evolving into a spectrometer.
Right. A standard camera captures light reflecting off an object to reproduce what our eyes see in the visible spectrum.
Just normal photography.
Exactly.
Okay.
But a spectrometer uses near-infrared spectroscopy to break down that light into its fundamental spectral components. It reads the unique optical signature of materials to analyze their actual chemical composition.
So in practice, you're sitting at a restaurant, you point your phone at the plate of food, and instantly, right on your screen, you see a complete caloric breakdown of the meal.
Yes.
Or you scan a wilted plant in your garden, and the spectrometer reads the soil chemistry to tell you exactly which nutrients are missing. You essentially have a chemical laboratory right in your pocket.
That's the material analysis side, but the second pipeline is just as transformative, and it has to do with high frame rate computer vision and spatial mapping.
Wait, this is the part where the text gets into analyzing micro-expressions, right?
That's the one.
I have to admit, when I read that, it sounded a bit invasive. Are we really saying the hardware is going to be scrutinizing our friends' faces while we talk to them?
I know, it does sound jarring initially, but think about it as an expansion of perception. We are talking about highly advanced spatial sensors processing high-fidelity visual data locally on that NPU.
Okay.
It can track tiny, fleeting muscle movements around the eyes or mouth that happen in a fraction of a second. It maps physiological responses that you, as a human, simply cannot perceive in real time.
So it could detect stress levels or really subtle emotional shifts during a conversation. The device is moving from being a passive lens to an active observer. It's becoming a brand new sense organ for humanity that sees the invisible.
It perceives the world with profound complexity. And because it understands context, material composition, and even human physiology, the way we communicate with the software has to evolve just as radically.
Right, because you can't have a device this intelligent and still force the user to hunt and peck through static drop-down menus.
Exactly.
So what does this all mean for how we actually navigate our daily tasks? The source breaks this down as the shift from command-based systems to intent-based operating systems.
This is a huge shift.
It really is. Right now, we operate in app silos. You have to speak the machine's language. You open a specific application, navigate a file system, click Save As, drag elements around. You are doing the heavy lifting of translating your broader goal into the specific micro-commands the machine understands.
It's a very rigid dynamic. You are the manager, but you are forced to micromanage every single keystroke of your digital subordinate.
But with an intent-based operating system, that friction is gone. You just state the goal. Take PowerPoint as an example. Instead of the absolute manual drudgery of formatting slides, importing charts, and adjusting fonts for 3 hours, you simply tell your system your intent.
You just give the directive.
Right. You say, compile last month's sales data into a presentation for tomorrow's meeting and send it to the board.
And the large language model running on your OS handles the orchestration. It pulls the raw data from your analytics software, generates the insights, formats it perfectly into your company's slide template, identifies who's on the board, and drafts the email.
All on its own.
Yes. It understands the context of your request and executes the sequence across multiple unsiloed applications seamlessly.
It's like having an incredibly competent chief of staff. But what I found even more compelling is how this intent-based OS merges with the sensor data we talked about earlier to create what is called empathic technology.
Empathic technology is the natural endpoint of an OS that truly understands context. It isn't just aware of your files, it becomes aware of your physical and cognitive state.
The mechanics of this are brilliant. The system analyzes local data points, your typing rhythm, your error rates, ambient light sensors, even how often you are pausing between tasks to gauge your mental energy levels in real time.
It's constantly reading your physical baseline.
And it maps those inputs to recognize when your focus is peaking and when you are crashing. Imagine it's 11 at night, you are exhausted, and your error rate spikes. Your interface detects that fatigue. Without you asking, it softens its screen colors. It actively suppresses non-urgent notifications, so a late-night email from a client doesn't spike your cortisol.
It's software that respects human biological limits. We are so used to technology that constantly demands our attention, buzzing and flashing, regardless of our physical state.
Always interrupting us.
Right. But an empathic OS acts as a buffer. It protects your cognitive load and your well-being.
Which is an amazing feature, but it immediately brings up the massive elephant in the room.
Privacy.
Exactly. If
Yeah.
this digital twin knows me that intimately, if it's analyzing my physical fatigue, tracking micro expressions, and crawling through all my financial and work data to build presentations, where is all this data going? Because handing that level of granularly intimate telemetry over to a corporate cloud server is a terrifying prospect.
It is the most critical hurdle for this technology to clear.
Mm.
If this data had to be processed in the cloud, the privacy implications would be catastrophic. But the solution brings us right back to our initial discussion about hardware architecture. The answer is entirely reliant on on-device AI.
Right. Because those NPUs are becoming so incredibly powerful, they are capable of running massive multi-billion parameter language models locally, directly on the silicon in your pocket.
You don't need to ping a server farm to process your intent. You can put your device into airplane mode, completely severing it from the internet, and your digital twin remains fully functional.
Even offline.
Yes, entirely offline. It can still build that presentation, it can still analyze sensor data, and it can still adapt to your cognitive load.
So your secrets, your intimate health data, your corporate finances, none of it ever leaves the physical boundaries of your device. Privacy is no longer a trade-off for intelligence. You get the absolute highest tier of personalized, context-aware computing without sacrificing a single byte of your personal data to a tech company's servers.
And establishing that absolute unbreachable trust is what allows the user to fully lean into the partnership. Once you trust the digital twin completely, it can begin to bridge external gaps between people in ways we haven't seen since the dawn of language.
Here's where it gets really interesting. We are looking at the total dissolution of language barriers.
This is one of my favorite parts.
Real-time, near-zero latency translation isn't exactly a new concept, but the breakthrough highlighted here isn't just about semantic accuracy. The real magic is a mechanic called voice preservation.
Traditional translation tells you what someone said, usually delivered by a very flat, robotic, synthesized voice. Voice preservation tells you how they felt when they said it, by separating the semantic meaning of the words from the acoustic features of the speaker's voice in the latent space of the AI model.
Let's ground this in a real example. Say you are listening to a content creator who speaks exclusively in Turkish. You don't know a single word of Turkish. With this local AI processing, you hear their words translated flawlessly into your native language, but you hear it in that creator's original voice.
The local model mathematically maps the translated phones back onto the unique vocal timbre, the pitch, and the emotional nuances of the original speaker.
You hear the slight breaks in their tonality, their urgency, their grit, their laughter, all preserved. It's seamless.
For creators, the need to artificially produce content in English to reach a global audience vanishes overnight. The entire world can hear your Turkish content perfectly spoken in their own native tongues without losing an ounce of your authentic identity.
It's the ultimate bridge for human empathy. We move past exchanging dry, translated text and move into truly hearing each other across massive cultural and linguistic divides, retaining all the subtle human elements that actually make communication impactful.
It's incredibly unifying. But it also leads to a fairly profound philosophical shift. As we hand over all of these complex tasks to our digital twins, real-time translation, cross-app orchestration, material analysis, managing our biological limits, we are essentially clearing out the RAM of our own brains.
That's a great way to put it.
By offloading the friction of daily mental chores to a trusted local AI, we create a massive void in our minds for deep thinking and creativity.
We completely free up our cognitive capacity. But this raises an important question, one the source defines as the skill paradox.
The skill paradox. Yes. If the machine starts doing everything flawlessly, if it writes our code, schedules our lives, formats our data, and translates our speech, will our basic human skills simply atrophy? If we strip away the struggle of learning these micromechanics, do we lose our edge?
It's a very real anxiety. I'll admit, I already rely so heavily on my GPS to get to a grocery store that's only 2 miles away from my house that I'm pretty sure my spatial navigation skills are entirely gone. If the digital twin does all the mental lifting, do our cognitive muscles just waste away?
It's a natural fear. But if we look at historical patterns, it suggests a different outcome. We aren't necessarily losing skills, we're moving up a layer of abstraction.
How so?
Think about the evolution of computer programming. Decades ago, programmers had to write in machine code punching in literal ones and zeros to make a machine perform a basic arithmetic function. When we move to high-level programming languages, Those programmers didn't lose their skills. Their skills evolved.
They stopped worrying about the micromechanics of the hardware and started building massive, complex software systems.
Precisely. The cognitive load was freed from the granular execution, allowing it to focus on architecture and design. We are moving from a paradigm of doing to a paradigm of directing. The source notes that the most critical skill set of the 2030s won't be rote memorization or manual execution. It will be AI orchestration.
AI orchestration. Managing a fleet of these intelligent agents. It's the ability to guide autonomous, hyper-intelligent partners with overarching human vision and strategy. The machine handles the perfect execution of the details, but the human provides the purpose and the soul of the project.
And as we shift into this role of directors rather than doers, the physical way we interface with these systems will also change. Right now, we are entirely dependent on screens. The glowing rectangle is our only bridge to the digital world.
But once you have an intent-based voice assistant that anticipates your needs and you pair that with highly capable augmented reality glasses, the necessity of staring down at a phone plummets.
The hardware essentially becomes invisible. It seamlessly blends the digital overlay with the physical world around you. You'll just move through your environment, talking, thinking, and directing, while the digital twin orchestrates the mechanics in the background. It represents the complete removal of friction from our daily lives.
It is an incredible picture of the near future. To bring all of this together for you listening, we are looking at a world just 5 years away that operates on a fundamentally different axis. We are transitioning away from the manual, passive, cloud-dependent smartphones of today.
That era is ending.
We are stepping into a world of autonomous digital twins powered by highly efficient local NPUs. We are looking at devices that can analyze the chemical makeup of our environment, operating systems that intuitively protect our cognitive load, and on-device AI that guarantees absolute privacy while breaking down global language barriers. It clears away the mundane friction of daily life to make room for AI orchestration and unparalleled human creativity.
It is a profound level of technological liberation. But as we wrap up today's deep dive, I want to leave you with one final thought from the source material to explore on your own.
Let's hear it.
Human intelligence and resilience have historically evolved through struggle. We grow by confronting obstacles, making mistakes, and figuring out hard things. So, in a near future where everything is completely frictionless, where our digital twins flawlessly handle every single complex detail of our lives, will difficulty actually become our new luxury? Will we find ourselves seeking out struggle just to feel human?
That is definitely something to chew on as we navigate these next few years. Thank you so much for joining us on this deep dive. Before you dive back into the rest of your day, look at that device on your table or in your hand just one last time, because very soon you won't just be looking at it, you'll be seamlessly experiencing the entire world through it, and that future is already arriving.